Okay, the main thing I want the viewer to take away from this video is that anything higher than a magic ghost number cube or a magic hybrid number cube, ghost and real numbers in this core, is that the outer ghost numbers on anything higher than a magic ghost number cube or hybrid number cube doesn't have a definite position around its area or around its volume. It doesn't even have a starlighted convex point or position where the outer ghost numbers would be. They're spread all up around, and I'll show you what I mean. So this is a magic ghost number cube, and it's an old thing I did. And you can see these diagonal numbers, inner ghost numbers, 18 and 18, 18 and 18, 18 and 18, 18 and 18. These four inner diagonal numbers produces 36 at all the corners. That doesn't happen on anything higher than a magic ghost number cube. Like, for instance, on this dodecahedron. It takes the average of these faces, these inner ghost numbers. I tried different groupings and none of them work except for this. It takes the 5 numbers on these vertices of this face to its counterpart vertices on this face. You do that for all 6 parallel faces. And I did that and I added them up, and I ignored this bottom part. I added them up on the top part, and there was some number, I forgot what it was, but you divide 6 into it and you get 390, which is 5 of the central ghost numbers. And it's always going to be 5 of the central ghost numbers. It doesn't work quite the same way with magic central real numbers, but with the ghost numbers, it's always 5. This is another example. Well, this is another example right here. All these numbers right here add up to 390, which gives 78, which is written on the surfaces with these. This is a hybrid number cube. It's written in the primary numbers and the output primary numbers in green, input in blue, output in green of a magic central real number hybrid number cube or dodecahedron. And as you can see, it takes the average. It's not even a starlighted point. It takes the average, and it does the same thing with this. I'll alter this a little bit. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this says 5, 6, and 4 because I changed the orientations of the placements. I changed the central real number 3 from 6 to 3, and then altered the numbers produced significantly, the 4, 5, and 6. And it does the same thing here. You add up all these numbers. I put them in groups this time, and you the final answer is 6 goes into 1800 300 times. 60, the central real number or central ghost number, goes into it 5 times, which is 5 again right here, and would be 5 up here. Would be 5 up here, which is what I've written down right here. And I had to go around the model to come up with these numbers. And it's 390 again. 6 goes into 390. And where 6 goes into this number. This is the number I've been for. 390 times. And 78 goes into 395 times. So, and it averages out. The outer ghost number averages out. There's no fixed point. And I think that's pretty magical in itself, or pretty ghostly. There's no set point where the outer ghost number would appear, like right here. You can't even make a group of these diagonals with a face. It just doesn't do that. It's an average of the outer ghost numbers. Well, thanks a lot.